Okay, folks, today we're going to be looking at solving rational equations. We're going to start off by looking first off at proportions. When you have a proportion, let's say that we were given the problem 5 divided by c is equal to 2 divided by c plus 3. What we have here is a proportion because we have a singular rational expression on the left side and we have a singular rational expression on the right side. To solve this, we are simply going to cross multiply. So we'll come right here and we'll say 2 times c, and that's going to be equal to 5 times c plus 3. 5 times c plus 3. We're going to do 2 times c, that gives us 2c. And using our distributive property here, 5 times c gives us 5c. 5 times 3 gives us a positive 15. Once we cross multiply and solve this, what we end up with is just a basic equation to solve. I'm going to come in here and I'm going to subtract 5c from both sides. 2 minus 5c gives us negative 3c is equal to 15. And then to isolate our variable c, we're going to divide by negative 3c, negative 3. And this is going to give us 15 divided by 3. Actually, how about 15 divided by negative 3? And that's going to give us c equals negative 5. Excuse me. Excuse me. All right, so our solution here is negative 5. And I'm just going to double check to make sure that negative 5 is not an excluded value. If I put a negative 5 in for c, I do not end up with a 0 in my denominator. And if I put substitute in a negative 5 here for c, I do not end up with a 0 in my denominator. So everything's good to go. That one. Once again here, we do have a proportion. I have a singular rational expression on the left side, and I have a singular rational expression on the right side. I'm going to simply cross multiply. So this gives me y times y minus 5. And that's going to be equal to y plus 1 times y minus 2. Using the distributive property here, y times y gives us y squared. Y times negative 5 is negative 5y. Folding this here, y times y is y squared. 1 times y is 1y. And negative 2 times y is negative 2y. So we end up with negative 1y. And then 1 times negative 2 is negative 2. Here I have a quadratic, so I do want to set this equal to 0, which is going to tell me to move everything to one side. I'm going to subtract y squared from both sides. I'm also going to add five y to both sides. Oops. Let's try that again. These cancel. These cancel, so I'm left with a 0. It's equal to my y squares also cancel. Negative 1 plus 5 gives us a negative 4. Then bring down the minus 2. I'm going to add 2 to both sides. I get 2 equals negative 4y. And finally, dividing by 4, or should I say negative 4, we get 2 over negative 4, and that's going to simplify to y equals negative 1/2. Now, we can always verify our solutions by checking this in Desmos. So going to Desmos. All right, on the left side, we had, and remember we can only use x, so we're going to change that y to an x, x over x minus 2. And then we had x plus 1 over x minus 5. And looking at our graph, we see, let me change this to a color other than black. Let's do purple. All right, and looking at our graph, we can see that it intersects only one time. So if I just click anywhere on one of the graphs, it's going to show me several points of interest. And the point of interest that I want is the point of intersection. And here we can see that we got 0.5, which is exactly what we got for our solution. And as you can tell from me sniffling and sneezing, they have turned the air on here, which is blowing all that dust into the classroom. So do excuse me for sneezing. Once again, here we have a proportion. We have a singular rational expression on the left side and a singular rational expression on the right side. I'm going to cross multiply. And at any time, you can pause the video. All right, distributing these. All right, 8 times x is 8x. 8 times negative 3 is negative 24. 1 times x squared minus 9 simply gives us x squared minus 9. This is a quadratic because it's raised to the second power. We have talked about the many different methods we can use to solve quadratics. You could solve it by factoring and using zero product property. You could solve by graphing. You can solve by Desmos. You can solve by quadratic formula. What I'm going to do here is I'm going to bring everything to one side, put it in standard form, and set it equal to 0. Since the x squared is positive, I'm going to bring everything over here to this side. So I'm going to subtract 8x from both sides, and then add 24 to both sides. These subtract and give us a 0 on the left side. Putting all this in standard form, my x squared would come first. My x to the first, my linear term would come next. And then negative 9 plus 24 is going to give me a positive 15. Using my zero product property, I'm going to solve this. So I'm going to factor this. The factors of 15 are 1 and 15 and 3 and 5. Well, we know that it's the 3 and 5 that would give us an 8, so we're going to use that 3 and 5. Negative was going to go with the 5, and a positive 3 times a negative 5 would not give us a positive 15, so that lets me this should be negative as well, because negative times negative is positive. And negative 3 minus 5 is negative 8. What I have done is I have put this in factor form, and by now we should be able to realize that here this is x minus my root and x minus my root. Roots are also called x-intercepts, which are also zeros, which are also solutions. So if we've got x minus 3, then that would be x equals 3. And if we've got x minus 5, that would give us x equals 5. So normally we would come right here and say, well, we got a 3 and a 5 for a solution. But since we've talked about excluded values, which we also said they were called restrictions, now we're going to also introduce a new word that means kind of the same thing. These are called extraneous solutions. And they all are some kinds of points of discontinuity. I don't think I spelled that right. Oops. Let's try it again. Discontinuity. There we go. All right. So they're all basically something that disrupt the connection of the graph. Okay, either by holes or asymptotes, they disrupt our graph. All right. So extraneous solutions are basically solutions that we find when we solve the problem, but they are not the true solutions because they're going to give us a zero. So look at your original denominators. We got x minus 3 and we got x squared minus 9. If I were to use an x value of 3, that would give me 3 minus 3 here and 3 squared minus 9 there. That would be a 0. We're not allowed to have a 0 in the denominator, so that's not going to work. 3 squared is 9, and 9 minus 9 is 0. So the 3 would be an extraneous solution. So that is not a solution. Let's try the 5. All right, substituting a 5, 5 minus 3, well, that would give us a 2. That's not a 0, so that's good. And then 5 squared minus 9, that's 25 minus 9. That would not give us a 0, so that is good as well. So 5 is going to be our only solution here. So the true solution is a 5. Majority of the time, you're always going to look for, when you have a quadratic in your denominator, you're going to always check for extraneous solutions because they seem to sneak up most of the time in in quadratics. But always check for extraneous solutions. But most of the time, like I said, they show up in quadratics. Okay. All right, so that's it with proportions. And now let's move into ones that would be like the regular equations that we have to solve. All right, we've got 4 steps that we're going to do. We're going to factor our denominator. We're going to get a common denominator. We're going to then simply focus on the numerator and then always verify your solution. Fortunately here, all the denominators are the same. So all we got to do is just look at the numerator. I've got 6v minus 6 plus 2 equals 1. This is just a regular equation we're going to solve. So 6v, negative 6 plus 2 is minus 4 equals 1. I'm going to add 4 to both sides. We're just solving like a regular equation. That gives me 6v equals 5, and then dividing by 6, we get v equals 5 over 6. All right, 5 6 squared would not give us a 0, so that lets us know that is an okay solution to use. Once again, anytime that you need to pause the video, please do so. I had to cover a class today, so I did not have my entire planning period. So I feel like I'm rushing a little bit to go through this. So you may just need to pause it sometimes to stay abreast with me. We've got to get a common denominator here. I can see that this has 5x and a square in it. This one has simply x squared. It needs a 5. So I will multiply the bottom by 5. But what I do to the bottom, I got to do to the top. I see this one just has an x. I need an x squared, and I need a 5. So I need to multiply the bottom by 5x. And what I do to the bottom, I got to do to the top. Once I get my common denominators, I'm focusing only on the numerators. So this right here is going to lead us to 5x times 4 is 20x plus 1 times 5 is 5 equals the 1. Again, all we're doing is just simply focusing on, we are simply focusing on the numerator. All right, I'm going to subtract 5 from both sides right here. That gives me 20x equals negative 5 plus 1, which is a negative 4. Dividing by 20. I get x equals, this reduces to negative 1 over 5. Right, if I substitute a 1/5 here, a 1/5 here, or a 1/5 here, that's not going to give me a 0 anywhere. So negative 1/5 is non-extraneous solution. It is the actual solution. All right, so to get our common denominators, all right, I see these two have x minus 5s, but it doesn't have an x minus 3, so I need to throw in that x minus 3. And what we do to the bottom, we got to do to the top. All right, I see that these two have an x minus 5, and this one does not, so I need to multiply the bottom by x minus 5, and what we do to the bottom, we got to do to the top. So now that we've got common denominators, we're only going to focus on the numerator. So let's multiply all this out. Following this, we're going to get x squared. 3x minus 5x is going to give us negative 2x. 3 times negative 5 is negative 15. X times x minus 3 is going to give us x squared minus 3x. And following these two, we're going to get x squared. 5x minus 3x is going to give us plus 2x minus 15. I've got to combine my like terms right here. So x squared plus x squared gives me 2x squared. Negative 2x minus 3x is going to give us a negative x. And this is no the 15th, no the constant, so we bring that down. We have a quadratic, so I want to bring everything to one side. Since the 2x squared is bigger than the 1x squared, I'm going to bring all this over here. So I'm going to subtract x squared from both sides. I'm going to subtract 2x from both sides. And then I'm going to add 15 to both sides. These cancel. And let's see, we get x squared. Let's see, did I lose a sign somewhere? I think I might have lost a sign. Let's see, let me go back right here and look. 3x might be negative 2x. Oh, right here. I left that out. Negative 2 minus 3 would be a negative 5. So this is a negative 5. I thought something was wrong there. So negative 5 minus 2 is negative 7. The 15s cancel, and we get equals 0. This is a binomial quadratic. So I'm going to just pull out the GCF because I can see they have a GCF of x. All right, so using the zero product property, I get x equals 0. X minus 7 equals 0. So our two solutions will be a 0, and adding 7 to both sides, we get a positive 7. Now let's double check those. If I substitute in a 0 for any of these x's in my denominator, they don't give me a 0 as the denominator, so that's good. If I substitute in a 7 in any of these positions for x, none of that gives me a 0. So here, our two solutions are 0 and 7. Okay, the bell's probably getting ready to get us, so I'll have to make the last two examples in a separate video. So let me go ahead and pause the video sharing right now. Obviously, let me find it. Where's my pause button? There we go.